Thanks for joining. Good afternoon, everyone. My name is Arnab Chatterjee. I work in one of the largest Japanese investment bank, and I had platform engineering there, primarily working into data and container platforms. Today, at OpenSearch we are talking about Kubernetes. Isn't it an irony? However, why not? Kubernetes is a fascinating platform. We all know about it. But in reality, it's found a lovely ally in OpenSearch, and that's why we're talking about it in this topic. No matter how much we praise and appreciate Kubernetes, let's be honest. When it gets wrong, you feel more like a detective rather than a platform engineer, isn't it? So what we'll do today, we'll see that how, when problems arise in Kubernetes, we can use OpenSearch as a magnifying glass and create solutions to problems that always existed in a more lucid and easy way. Here we go. Now talk about observability. Observability is very close to monitoring. Somehow people swap both of them and relate both of them. But it's more on, monitoring is more on the state and observability is more on the behavior. So when monitoring gives you a solution like why this is up and why this is down, observability will indicate that why it is behaving in that way. So in Kubernetes, like a lot of other platforms, the foundation of observability rests on three main pillars. Logs, the contextual details at the pod, nodes, and application layer. The metrics, which are nothing but numeric trends and thresholds across the pods, nodes workload, and traces. And traces are request level flow across the distributed microservices. And if I'm going to talk about it and relate it to an analogy, I would say that if you have a patient in hospital, then logs are the records of the patient, metrics are the vital signs in the monitor, and traces are the MRI scan. They would show you the flow internally across the services. And apparently you need all of the three together, correlated, to get the full picture. If that's not the case, there is a gap. You just spoke about the gaps. Now we'll talk about what are the major observability challenges. Kubernetes is different from other platforms because of its nature. The inherent nature of Kubernetes being ephemeral. And it is, isn't it? Pods disappear anytime, IP addresses change, the workloads would scale up and down automatically. Let's say you're debugging a failed transaction, and the pod that did it has terminated. So you need the logs that do no longer exist unless you actually ship them out. Metrics will show you the spike, but they don't explain why. And then traces are fragmented if they are not collected consistently. So the hard part isn't really collecting data. It is correlating it across namespaces, nodes, and even clusters. And that is where the two sprawl will make life really difficult for you. The question here is, we spoke about OpenSearch being an ally to Kubernetes, but why use OpenSearch? The question keeps pondering. Now, a lot of companies, they talk about portfolio rationalization. We have Kubernetes and we have got 20 different companies spawning out of it just to provide observability on top of Kubernetes. In your company, in your organization, if you're already invested with OpenSearch, can you actually leverage it? Have you really thought about going to that detailing, or we just pigeonholed OpenSearch to just look at logs? We'll find that out very soon. We keep on hearing this from our friends from the Grafana stack. You have got Prometheus for metrics, Elk for logs, Tempo for traces, 3 different storage backend. Technically it works, and that's how we've seen it getting implemented in a lot of organizations. But what it does, it creates operational silos. And you have different query languages, PromQL versus Lucene versus TraceQL. You got 3 different storage backends, and you don't get any native correlation out of the box. So what happens in practice? Your on-call engineer is spending more time context switching than actually solving the incident. And yes, the case for consolidation here is real. And that is why OpenSearch is being discussed here. You have got a platform in your organization. You got the people who use that platform, are aware of it. So rather than bringing in a new tool, look at it, take a look at it if it actually is good enough for certain use cases, so that your licenses get utilized, your skill sets are getting utilized, instead of rather building something from scratch. So yes, here is where OpenSearch comes into the picture. We spoke about OpenSearch. We know OpenSearch as a forked version of Elastic. It isn't really only a search engine. It is actually a distributed analytics platform with a pluggable ingestion layer, and it could be like a plethora of things like Fluent Bit, Fluent D, Logstash, Beats, various different collectors. It has scalable indexing and sharding, built-in support for time series metrics. You got trace analytics with OpenTelemetry integration and visualization through the dashboards, which comes out of the box. So the key strength here is unification. You don't need three backends, logs, metrics, and traces. They can all live in OpenSearch. They can be indexed and queried together. Now let's take a look of what happens under the hood. Keep on talking about three different backends, and here how can one backend really work? So let's try to break it down into logs, metrics, traces, how the data flows into the system, and how the dashboard comes into the party. So four main features here are, number one, ingestion. So when it talk about ingestion, it's about getting the data into the platform. So logs flow into the platform via something like a Fluent Bit or Fluent D. Metrics comes from Prometheus, exporters, and traces from the collectors. So everywhere there's a different endpoint, but they all land in the same place. You talk about indexing, data is sharded across the cluster. So you get high throughput, you have a hot, warm, cold node tiering to manage storage costs in case of a bloating and explosion of storage. You talk about querying, which is the third feature. Lucene is a standard backend. So you use Lucene query for logs, time series, metrics, everything, traces, rather than having three different nature of backends. Security is fine-grained RBAC. So instead of stitching multiple backends, you rely on one distributed data store with well-defined API. Of course, it's got its pros and cons, which we can cover later in Q&As. But that's how it actually completes the circle of having a single unified approach. So we spoke about logs, metrics, and traces. Let's see what is in place in Kubernetes when we don't have this correlation and association together. So as you can see, the sad face of the crash loop back pods with multiple replica set running over different nodes in the cluster, and the guy who is hopping between nodes, running multiple kubectl commands, trying to extract information, plain text, getting the logs, and then trying to filter it and do the data massaging. It's apparently a very, very painful task. So best practices is, logs basically are the baseline of your systems. You have to have a structured log. So basically structured JSONs make querying in OpenSearch far more powerful than greping log files. So step one is enforce structured logging at the application layer. Use dynamic index templating for log types, and you have your logs segregated and defined in a very lucid and clean fashion so that they can be identified and queried similarly. You talk about data retention to avoid bloating. You retain hot logs for 7 to 14 days and then archive the rest to S3. So basically in production, this means you can pull logs across all namespaces in a Kubernetes in seconds, even if the pods do not exist. No longer jumping up from one machine to other. Have a consolidated daemon set or some kind of collector that would do the job for you, and throw the data into OpenSearch. We come to metrics. Now metrics, going back to the hospital analogy, it's the heartbeat of the system. It's not only about CPU and memory. You get a lot of other data about scheduling delays, disk pressure, node compression, anything and everything. These are like very, very important. So these are ingested by OpenTelemetry, and key technical advantage here is storing metrics in OpenSearch. It by default enables correlation with logs by timestamp or pod level. So when you do that, the backend storage backend, the way it defines is, it by default does a primary referential integrity secondary key between the trace and log entities. And this correlation drastically reduces your MTTR. So you don't have to flip between like a Grafana and Kibana to overlay CPU spice and logs. A single pane of glass will give you the correlation together. Traces, logs are fine, they are good. You have a problem, you have a breakage of service. Logs will give you a complete look of what went wrong. Errors are easily visible, they're very prominent. Traces are not. Latency, slowness, trying to identify why did it happen, where did it happen, is the most challenging part. A good example is here. For example, this is an example of a microservices going slow. You can see a user request goes through ingress, then an API gateway, then a chain of microservices. It could be a service mesh as well. And finally, it enters a database. Now, how do we know where is the bottleneck here? The answer are traces. It is a part that closes the loop. So every request gets a trace ID. That trace is propagated across services via the instrumentation. And then OpenSearch stores, spans, aggregates them into traces, and lets you drill into the slowest call. So this is just not a visual candy. It's crucial for debugging any distributed system where latency can hide deep into something like a database or a service mesh. And in a platform like Kubernetes, this is something that exists of pivotal importance. We spoke a lot about data. But now, when it comes to showing the data, is the visualization part. Uh, so yes, OpenShift also comes, OpenSearch just comes with its own visualization dashboard. It is a fancy dashboard which has visualization for latency, error rates, restarts all in one place. You can have alerts configured to fire when the thresholds are crossed, etc. So you basically can build unified dashboards mixing log traces and metrics. You can use filters to pivot quickly around a namespace, pod, or trace ID. And finally, correlate anomalies without leaving the user interface. For example, if you notice a latency spike, you overlay metrics with the trace, drill into the logs, all in the one place, instead of jumping and hopping from one area to the other. We'll see a good example of how you would troubleshoot a workflow. This is a typical example. So you see an alert getting fired, indicating the latency is high. Try to join the dots, you go to the metrics, the second pane comes up, you see the metrics, you look at the node resource pressure, it's spiking up. And then you go and pivot into log directly from the interfaces to find the stack tracing pointing to the misconfigured pod. So what you do, you get the complete circle. What happened, from where did it start? And then from the status, from the traces, you can confirm which service was a bottleneck. And the entire flow happens inside OpenSearch, no tool hopping, no context switching. We spoke a lot about cluster, but in reality, most environments are multi-clusters. You'll have your estate deployed across multiple regions, multiple data centers, multiple setups. So it's a multi-cluster environment is most of the organization. And that's why, when we talk about searching, querying, and correlating, you want to do it across different systems which are physically not same. They might be geographically distant. So there is a pattern in OpenSearch to do that as well. You can run federated queries across clusters using cross-cluster search. You centralize the observability by retaining local collection. And then you have your index lifecycle management that offloads to old data to object store, keeping the cost predictability, because this is one of a very important point when you start ingesting so much amount of data is to make sure your costs don't really bloat out. So in practice, dev, staging, production cluster all ship into a shared OpenSearch domain. So you have the golden source of the Kubernetes data in one single domain, and you can separate by index, preface, namespace, or cluster label. And this scales horizontally, and you ultimately don't end up having multiple silos. You get one lens to look through it. As we spoke about, the magnifying glass, you get it directly out of the box. Next is we will talk about a real-life use case. So this is an implementation of a use case where a big financial bank migrated their existing setup from a different observability stack to OpenSearch and how it helped them. So the application was, of course, it was a Kubernetes application running on-prem. It had its own setup in terms of the backend and observability. So when they moved to cloud, it became like a hole in the pocket with respect to the cost. OpenSearch was a choice. They evaluated it, and what they did is address the challenges that they had. And the main challenge, apart from the Kubernetes short-lived pod, was data silos. So what they had was they had multiple backends in place by default. So they had Prometheus for metrics, the Loki Elk stack for logs, and Jagger for traces with a Cassandra backend. So 3 storage backends to maintain, no correlation between the system. As I maintained, engineers manually stitching trace ID into Kibana searches. There was a cost sprawl because he had duplicate storage of timestamps and labels across the system, while it didn't really bite them on premises. In cloud, that became a massive problem. And they went to a solution where they stitched all together using the points that I just mentioned in my earlier slide, having a correlated view with logs, metric traces in one plane. The implementation by default was you had Fluentbit daemon sets deployed into the cluster, feeding into OpenSearch. And we had the OpenTelemetry collector scrape metrics exporting directly into OpenSearch. And then he had index lifecycle policies to make sure that data moves from warm to cold. You had the dashboard that unified metrics overlays. So immediate result was the MTTR reduction by 70%, which means that the time to solve a problem, exposing it, was drastically reduced. And the storage footprint was reduced by 25% because there were a lot of duplicate indexes, especially in the logs and traces part. And most importantly, what happened was the existing on-call engineers, they stopped juggling multiple dashboards and could pivot by a single trace ID. It was a success story which probably saved a good amount of money during the migration. So before we wrap it up, we spoke about Kubernetes. It is complex, but it is not optional. Observability in Kubernetes is something that you cannot get rid of. And without it, you are actually flying blind. It's very difficult to find out, identify things when things go wrong. Logs, metrics, traces need to be unified, not siloed. OpenSearch provides a single backend, scalable architecture to a certain extent, and a unified interface. And the impact here is it's not really a convenience. It's reduced downtime, faster root cause analysis, and lower operational cost. So with the right observability strategy, your midnight alert doesn't have to turn into a 3-hour war room. It can be a quicker fix. With that, I would like to conclude. Thank you. Happy to take questions. No questions? Okay, thank you. Yeah, sure.
Is there anything that is needed to done for connecting tracing with the machine logs in OpenSearch? Other than what we already need to.
Can you come again? Louder. You can use the mic if you want. They need to hear, yeah.
So I was wondering, like, for tracing, because I haven't really touched tracing in a while. So to set up tracing in OpenSearch, and provided we already have metrics and logs enabled, is there anything else that we should integrate in order to set up the tracing
So
pipeline?
the key part about tracing is getting the traces into the OpenSearch. So there are ways to get traces. Basically, there are collectors. You talk about Kubernetes, you can run it as a daemon set. But ideally, it's a simple story. There are things like fluentd, fluentbit to push logs. And there are metric collectors to put metrics. Similarly, for trace, you use, if you've worked with Jagger or Tempo, there are ready exporters and collectors. You should ideally use a collector, not an exporter. It should be an independent service running, and that would take the traces. Defining traces in the application is more important because it doesn't come out of the box. So the application, when you are writing logs, traces, you should define what is trace and what is logs. So that's an effort. That's a one-time effort that you need to do while building the application. Because we've been running applications for a long time. We've been doing logs for ages. We didn't do traces actually. Because that correlation ID, that has to go to logs and traces. They need to get married to each other to have that direct linkage.
So we basically need another set of collector for a different type of data, the tracing data for the tracing pipeline.
Yes. You need to have a collector and you need to define tracing because majority applications don't have tracing. So when they don't have tracing, they can't push the traces. Yeah. Yeah. Okay. Thank you. Yeah, sure. Okay. So I'll tell you the difference between OpenSearch and a Grafana stack. When you talk about Grafana stack, so in Grafana stack, which is very popular, you have different 3 backends. Prometheus is for metrics, Loki is for log, and Tempo is for traces. What systems like OpenSearch and Elastic do is they give a unified storage layer. It's Lucene. So you don't really need Prometheus here. There's a caveat. I'll tell you what happens. So whatever you push, it gets pushed into the single backend storage layer, which is Lucene. Everything is inherently getting stored as JSON. The JSON formats are different. I mean, like you would be asking, how can you store time series in JSON? Because ultimately, Prometheus is meant to store time. It is an TSDB. This is not. But there is an observability OpenSearch plugin that allows you to do this translation. But there is a catch. The problem is traces, logs, metrics can all be stored in OpenSearch. However, there is a cost to it. The way your Prometheus will store time series data, it will be a lot more compressed, smaller footprint. It will be more scalable. With Lucene, there is a bit of a performance overhead when it comes to metrics, and there is a cost. But I think as long as your footprint is not massive, you are okay. We've done some analysis on it in the organization. So there's a sweet spot that if you cross that, you hit it, then it's a problem. But you don't need Prometheus with OpenSearch out of the box. If you still want to use Prometheus and the UI, you can use integration components. But ideally, the theme is that unified storage layer. No, there is no such solution. It's like, I could say it is like a Swiss knife which you use to have multiple purpose served. Yeah. Sure. I think that is a possibility if you have integrators. You have to have an integration component where you can just use the UI. But then the system is different. It's a disparate system. The UI can be, it's a UI, but it is talking to another system. It's like a hook. It doesn't come embed. So the correlation again would be a challenge because it does the correlation and push down at the storage layer. Here it would have to do in memory. And when it does in memory, it won't scale really well. It won't have the sharding effect. All right. Thank you for attending.